live and we're recording. So we're going to be going through questions from Polarization. This is going to be 2023 October, Unit 2, Question 10. You can pause the video and try it out. And let's start solving. So two photographs, X and Y, were taken of the same car windscreen. Photograph Y was taken through a polarizing filter. And then you have both the photographs. And then it says which row of the table is correct. So we have light transmitted through windscreen and we have light reflected. So light transmitted and light reflected. And we have to see which one is going to be polarized and which one is going to be unpolarized. So what light are we talking about specifically? We're talking about the sunlight. So sun is going to hit, the sun rays are going to hit, and that light, some of it will be transmitted through and some of it will be reflected. So some of it's going to pass straight through and some of it is going to reflect towards us, and we're going to see through the photograph. So if you have a camera and you're recording and you have the windscreen, the light that is reflected is going to hit you, right? And then you can see the object. So we're talking about that reflected light, and then when we say the transmitted light, we talk about the light that passes straight through the windscreen. So we want to see what happens. Does polarization happen or not? So I've drawn a small diagram here to help you understand. So we can see that this is going to be my windscreen, and then this is my unpolarized light that comes from the sun, unpolarized light. And when the light is transmitted through, it's going to remain unchanged. So it's going to remain unpolarized. Okay. So this light has oscillations in all directions. It's unpolarized, so it can either be C or D. The next thing, when the light is going to reflect, it's going to be partially polarized, but I'm not looking at that. We're looking at the filter, okay? Because the question tells me a very important thing, that photograph Y was taken through a polarizing filter. Now we have learned this in class, that whenever reflection happens, there is going to be partial polarization. But we're not looking at that. We're specifically looking at plane polarization. And you can notice that here, the other vibrations are much more reduced. But they are still there. And they will completely be reduced when, or absorbed actually by the filter, when they pass through the filter. So the filter is going to cause the light to go from partially polarized to plane polarized. Okay, the other oscillations will be absorbed and the one that's parallel is going to pass through. So then light will become polarized, right? So it's less about the reflection part, it's more about that we have put the polarizing filter. Okay, so because of that, the light becomes polarized. So this is going to be plane polarized, so it's going to be C. You can also see the mark scheme for this. They give the same reasoning. Answer is C, and they tell you why the light is polarized, because it is absorbed by the filter that's placed right over here. And where is this information? It's given to you in the question right over there. So I'm going to connect this to the question that we had. And what I'm going to do here is we're going to talk about glare. What do we mean by glare? And how do we reduce it? And why are polarizing glasses so good at reducing the glare? So you can see that the sunlight is here and it hits the water surface. And we can see that the rays have oscillations in all directions. So we have unpolarized light right over here. Now this unpolarized light, when it hits the surface of water, is going to reflect. And we can see that the horizontal component is significant here. And this horizontal component actually causes the glare. Okay, it causes the glare. Now, what happens is this affects, let's say you are here, you're trying to see what's in the water. This horizontal component is going to affect the ability to see in the water. Okay, and you're not going to be able to see clearly what's in the water because of this horizontal component. So what we do is we want to get rid of this horizontal component. So we're going to wear glasses that are vertically, that have these, that are vertically polarized. Now, what I mean by vertically polarized is that their axis of transmission is vertical. Okay, so we can write it down here. So vertically polarized. Okay, that would mean that the axis of transmission is vertical. Okay, so the horizontal light that we have there is going to be absorbed and the glare will be reduced. Well, glare looks something like this. This is what that horizontal component does. And when we get rid of it, bam, we can see clearly inside the water. The same thing here as well. Look what happens when there's glare. Without glare, we can see clearly. And this is another diagram that we can see here. So we can see the reflected light, horizontal component, we get rid of that. So now I want you to pause the video and read through this. And yeah, I hope all of this helps you to understand the concept. That's all.